Hey Brandon, this is Mr. Caslin. I wanted to go over this trig problem we were trying to solve at the end of our session this week. I've got an approach that seems to work well, and let me run it by you. I think we were on the right path. We know that tangent is equal to the sine over cosine. I apologize, I don't have a good writing utensil for my computer, so I'm writing with a mouse, which doesn't come out very well. And I'm going to abbreviate a little bit. I'll put the x's back in at the end, but to make this as short as possible, I'm going to abbreviate a little bit. We know that cotangent is cosine over sine, and we did know that this looked like we could use a double angle formula. We're going to get 8 sine of x cosine of x just by multiplying the 2 by the 4. Okay, now what I discovered, one of the things that you can do is let's just multiply this entire equation by the sine of x. You could have chosen cosine also, but we'll try sine first. So when you multiply every term in the equation by sine of x, you get a sine squared over cosine the sine in the numerator will cancel this sine in the denominator, so you'd just be left with a cosine, and this sine times this term would be a sine squared. Ooh, that's ugly. Sine squared cosine. Again, your teacher's going to want you to put the theta or the x in all of these, but I'm leaving them out just to get through this quickly for you. Now, what if we also multiplied everything by cosine of x? Both sides of the equation. Cosines in the numerator and denominator would cancel. You'd get a sine squared x plus cosine squared x. There's our beloved identity that makes things simplify nicely. Equals to 8 sine squared x cosine squared x. Okay, so I've multiplied everything by the sine, everything by the cosine. This gives you a 1. You're going to divide both sides by 8. So 1/8 is equal to sine squared cosine squared. So I'll put the x's back in. Sine squared of x times the cosine squared of x. Now, notice these two factors are multiplied together. Since they're multiplied together, we're allowed to take the square root of both sides. Okay, this would just be like an x squared, y squared. Take the square root of it, you get xy. So what we're going to get is sine of x cosine of x on this side. On this side, you're going to get, don't forget plus or minus. Oh, plus or minus. Yep. Plus or minus square root of 1/8. Now we can rationalize this denominator. Square root of 1 over square root of 8. That's going to be 1 over square root of 8. I know you know how to rationalize denominators, so I'll jump forward to square root of 8 over 8. This is 2 square root of 2, so we end up with square root of 2 over 4. So what we just did is just simplify these. Alright, I need to run out to Best Buy, get a stylus to write with, obviously. Okay. Alright, so square root of 2 over 4. Now, what can we do with this over here? Well, doesn't this look similar to double angle formula? What if we multiplied both sides by 2. Okay, we'll use this step as the simplification. I'm going to multiply both sides by 2. That'll be like a 1/2 square root of 2. Keep going in blue here, so we get plus or minus square root of 2 over 2. That's a familiar trig value. And this is 2 sine x cosine x. Okay, this side's our trig identity. Well, not really trig identity, it's our double angle formula, really. So sine of 2x. So here's a problem where we used the identity twice. We turned it into this form and then went back and turned it into this form in the end, because we started with a sine of 2x to start with. Okay, so we know that 45-degree angles create square root of 2 over 2. So this is saying basically if 2x is equal, sine of 2x is equal to square root of 2, what is x going to be to create a 45-degree angle? So basically x would have to be 22.5 degrees in all of its variations. I'll let you finish that out, figure out around the unit circle where this is going to be true, because it is a plus or minus. Okay, so 45 degrees is 1/2 of 45. So that's your pi over 8. Okay, anyway, the answer is all of the, go around your unit circle and figure out all of your angles that are going to give you the plus or minus square root of 2. Anyway, this approach seems to be best. You could multiply by sine x cosine x at the same time. I just found it worked nicely and simplified nicely. Start out with the sine of x, go with the cosine of x, and then you can take the square root of this term here. So if you've got things that are multiplied together, like a sine squared of x and cosine squared of x, you can take the square root of that value. Okay, sorry to be long-winded. Hope this helps, and I'd be interested to know if how your teacher solved this. Talk to you later.